Alright guys, I just wanted to make this update video. Earlier in a previous class, one of our students brought in this Boss drum machine and it wasn't turning on. It wouldn't turn on with batteries, it wouldn't turn on with the included wall wart power supply. And then we opened it up and determined that the switch, the power switch, right here, had failed internally and it wasn't connecting where the power comes in to the rest of the power circuit and on into the rest of the drum machine. So none of these components were getting the power they needed to turn on and start working because the switch had failed. So the way we solved that, and of course the correct way to solve that is to go to Mouser.com or an online parts supply store and get the same exact switch, which is the same size and the same number of legs and the same everything, and then install a new switch. Obviously this has got some corrosion on it and that kind of thing. So you would get a new switch and install it. As a temporary fix, what we did in class, if you were there you'll remember this, is we took a little short piece of wire, an insulated piece of wire, because we don't want this. We don't want to use just bare wire because we might cause a short unintentionally. And we connected, our ground connection was fine, but our power wasn't getting across, so this is actually a tip negative connector, so that power was supposed to go down this trace that you can see here to this leg of this switch. I'm sorry that the camera is shaking. I'll try to control that a little bit better. And it was supposed to come here, and then when the switch is on this side, as you see it now, it's supposed to make a connection from this middle pin to that, and that would bridge that gap there, and then power would get into here and go on to the rest of the circuit board. But this wasn't happening. We cleaned the switch, we used a little isopropyl alcohol to try and clean out some of the grime. We exercised the switch back and forth a whole lot to try and scrape out any corrosion that was in there. I think something got spilled on this drum machine, I'm not sure what. But anyway, so instead of using the switch then, we just basically have bypassed the power switch by connecting where the power comes in directly to the rest of the circuit. So basically anytime he either puts batteries in this thing or connects it to that wall wart power supply, it'll just pop on, and then when he wants to stop using it, he will just disconnect the power and it'll turn off. So we powered it back on, and it did, after we were done working on that little jumper wire, it actually turned on. So that was great, but we still had a problem because the rotary encoder, that's this little thing, it looks like a variable resistor, doesn't it? It is not. It is a digital rotary encoder, and you can just spin it and spin it and spin it, and you can hear it kind of, it's got little notches. You hear that? It's got all these little, you'll see these on the front, like the big knob on your home theater system is probably a digital rotary encoder. Basically when you turn it clockwise, it sends a little signal to, a chip that it's attached to that says, +1, and then whatever setting you're adjusting at the time on the screen will go up 1, and if you turn it counterclockwise, the other way, it'll send basically a -1 signal every time you click it one step, and then the little parameter that's on your screen will tick down 1. So it's not actually a potentiometer, it's not actually a variable resistor. But anyway, we powered this thing back on after we had successfully sort of reconnected the power internally, and this thing doesn't seem to work. So we're going to take a look at that. I'm going to flip over the circuit board and we'll have a look. So check this out. I'm going to try to get a picture of this, but it's going to be really small. Okay. See if I can get a good angle on this. if you look really closely, this is basically just, this is a big solder joint that's connected to that potentiometer. Here's another solder joint that's connected to that potentiometer. These are actually, I don't think these are actually electrical connections. I think this is just for stability. These are just metal tabs that you can solder onto the opposite side of the circuit board to hold I'm sorry, I used the word potentiometer, the digital rotary encoder in place. But these, 1, 2, 3, I believe, are the actual electrical connections for the digital rotary encoder. So what we're going to do, if you look super close, you can kind of see there's a crack. There's a crack in this little solder. You notice there's not very much solder here at all in the first place, but if you look super close, there's just a hairline fracture in each one of these, on each one of those solder joints. So I'm going to resolder those and just add a little bit of solder, reflow those connections. We're going to reassemble and we're going to see if that thing starts to work. I went ahead and resoldered those 3 joints that we talked about a minute ago. Actually, I resoldered them twice because when we put it back together and turned it on and tested it, we were actually getting, the rotary encoder actually worked, and I was able to adjust the tempo up, but whether I was turning it clockwise or counterclockwise, it was going up in tempo. But then I resoldered it a second time, and then it started working properly. I actually also reseated those ribbon cables, which may have been part of my problem, but it seems to be working now. See, I can turn the tempo down, and then I can turn the tempo up. So this rotary encoder is definitely working, although it does have a lot of corrosion, and I think I'm going to use some isopropyl alcohol to clean out some of that gunk in there. Although you do need to worry about, like, that isopropyl alcohol that I'm using is 99.9% pure, and it can actually corrode and eat away at some soft plastics. So I may just leave that like it is and call it somebody else's problem. But this device seems to be working now. Okay, update. After reassembly, it still didn't work. So I desoldered the digital rotary encoder from the circuit, and you can see that there's a lot of corrosion here. Like, there's some funky stuff. Kind of all over the place. So here's the 3. These 2 big legs are just for support. This one and the one on the other side just to hold the thing in. But these 3 legs that you see here are actually for electrical connections. Now I've used continuity, and if you probe from the middle leg to the outside legs, from the middle leg here to either one of the outside legs, and you rotate this knob, you get a real quick beep. So this is working. It's actually, despite all how ugly it is, it's working. But if you look at where it was in the circuit, if I look at these solder pads, this is not looking great. This is not a happy looking solder pad. They look pretty mucked up and corroded. And it looks like this solder pad was supposed to be connected to this little trace here that went kind of up and over. This white outline is not a conductive trace. But I need to make sure that this middle pin is connected to that trace that goes kind of down this way. And I think it goes to that resistor right there, that R13 maybe. I need to make sure that this solder pad, or that leg of the digital rotary encoder, gets connected to, where it's supposed to go. It kind of goes underneath that white outline. I got to kind of figure out where it's supposed to be connected. And then this leg needs to be connected to this ground plane. So I need to make sure there's continuity from that leg to this. So I might have to scrape off some of this insulation and just solder that directly onto there. So I'll do that next. Alright guys, so I gave this another whirl. As you saw, I took out the digital rotary encoder and it had some corrosion on it and stuff like that, and the solder pads didn't look great. I figured out, based on where the traces were, where each of those 3 legs from the digital rotary encoder were supposed to be connected to. in the rest of the circuit, and I confirmed that the solder pads that I was able to solder on were actually connected to those. So I stuck the digital, and I also confirmed that the digital rotary encoder was working by using continuity between the legs and then rotating the actuator. So I knew it was working, and I knew the traces that where it's supposed to be put into the circuit board were connected to where they were supposed to be connected. And then I resoldered it into the circuit board, and I've got it mostly reassembled here, and it looks at this point like it's working. So if I rotate up, I'm able to increase values on the machine and then rotate counterclockwise to decrease values. So it looks like we got this fixed. Now, of course, I'm going to reassemble this, and it's going to stop working because it's a jerk, and it hates me. But I think this is fixed. This is officially fixed now. I declared it. All right, and here it is, finally completely reassembled with the big knob put back in place and in working condition.